ignition or starting systems, more what is all the deep principles behind that, because you get that in your ignition starting class. So talk about what you need to know for testing, what is unique to turbines. So ignition, if you're going to your lab, and then manuals, ATA chapter 74 in the manuals. And, all right, what do you know? Have you talked, I know you're talking about ignition, have you talked about turbine ignition yet in ignition class? Okay, good. You'll get more, okay, great. What are you, I think I heard, talking about ignition relating to recip engines. What is something you have to do with your magnetos when you put them on a reciprocating engine?
Time.
You have to time them. Does anybody understand how to time a magneto to an engine completely, thoroughly? Inside out, upside down, backward, you can explain it to your grandma that she can do it herself.
Your 80% Randall's not here today.
Wow. So, here's something I really like about turbine engines. There's no timing. They don't got no timing. They're cool. They know what to do because we don't have pistons doing all sorts of things at all different times. What is unique about the Brayton cycle compared to the Otto cycle? Everything is happening all at once. Continually having intake, continually having compression, continually having combustion, continually having an exhaust. Beautiful. Constant pressure. So, no timing. You use the ignition system to ignite the fuel. And then, once you come up to self-sustaining speed, turn it off, done with it. Unless you have flame out or other stuff we're going to talk about. But there are two systems you do need to know about for the test and for turbines. So ignition systems on turbine engines, it's a capacitor discharge ignition system. And you will have high tension and low tension systems. And we'll talk about those too. You'll have intermittent duty cycles where it will have a very high current draw to give the power it needs, and that will have what's called a restricted duty cycle, so you can only have those on for the manufacturer's specified amount of time, and then you need to give it a cool down time, and then there's a limited amount of time for it to be on again. So you really have to go pay attention to your manual. And then extended duty runs not quite as powerful, so you can have it on for longer and not hurt anything. The reason that they have to have such extreme high voltage compared to recips, actually let me ask you guys why, before I give you answers. Why do we have to, and we'll talk about what volts and joules they run at in a minute, but why would we have to have much higher on turbines? Yeah.
Is it anything to do with like a glow plug or something? Or?
We're going to talk about all that, but glow plugs are old,
Right.
so now we have igniters.
Larger spark gap.
Yes. Larger, yeah. Excellent. Yeah.
Maybe also the jet fuel
You're on the right track. So we, compared to recip, are running at a much leaner mixture. So it will take more to ignite that compared to recips. And compare, yes.
At startup or across the board? Leading into the second part of that question, is stoichiometric still a thing? Or
Yes.
is it just,
Yes. So once we get full fuel, everything in there, it will be very close to stoichiometric on a turbine.
But not at initial start.
Right. I think I mean, you're still trying to add the right amount of fuel and air.
Yeah, it's got the right amount of fuel and air to ignite and accelerate. It's
Where
probably a little
at-
bit more richer because you're accelerating.
And then compared to that, like, you're very rich on a startup for a reset. Comparatively.
Okay.
So it's not so much that the turbine is changing
Right.
its richness, it's the fact that on a reset,
Correct.
we're very rich.
Correct. We're comparing turbine and reset. Why do we have to have such powerful spark igniters on our turbine compared to spark plugs on a reset? Yeah.
Okay.
And then comparing those two, what do you think is the difference between our airflow around a combustion chamber on a turbine compared to air in our cylinder? When we're bringing in air, introduce a spark, and then introduce fuel, what's the difference between airflow? Yeah.
In the turbine, it's constant, but in, it's more like you have your compression and, exhaust, right?
You are on the right track. Yeah.
It inspired me. Recip is like intermittent, so to speak, even though it's incredibly rapidly intermittent. So air's coming in, then it stops.
Yes.
Whereas
Yes.
for turbine,
Yes.
it's continuous.
Yes. And we have relatively speaking, high velocity airflow shooting through here. Where here it's like, hello. I mean, you are right, we got it, that piston's still moving, but we have time where, all right, settle down, out, settle down, out. So, yeah. Yeah. Questions on any of those? Of why we have to have very high power. I'm gonna mention this several times. These guys are deadly. If you do not follow maintenance procedures to give them a cool down, dissipate period, it will kill you. So if you go up to an engine that just ran and you try to take out your spark igniter, goodbye. So keep that in mind. After a normal start, ignition is no longer needed, so you deactivate the system. So unique to turbines, only running during start, except for some exceptions. Question?
Yeah, one with that, for you,
We're going to talk about that, how many volts it has, on the next slide.
for how long after it shuts down.
Good question, we're going to talk about that one. So, normally you turn ignition off, except if you are going to fly into bad weather, like rain or ice, or taking off from a wet runway. So on the King Air, those of you that ran it up, you noticed that we made sure auto ignition switches were off. If we knew we were going to fly out into cold, rainy, yucky weather, we would turn auto ignition on. We'll talk about those more later also. But that just arms ignition switch. So if it senses the flame might go out, it automatically puts ignition back on. So you don't even have to take the time to realize you have a flame out, reach over, turn ignition back on. And then, yeah, if you're taking off from a wet runway or anything that you determine you might get a flame out, then you can leave your ignition on, but normally deactivate it after start. Our classifications again, high tension, low tension. Engines will have typically 2 igniter plugs per engine in the 4 o'clock and 8 o'clock positions. Boink, boink. And that is sufficient to ignite our fuel. And then typically you'll have 2 exciter units, very exciting, which is right here on this And then same thing on the other side of the engine, which you can't see because the engine's blocking it. They can be input 28 volt DC or 115 AC, and we're going to talk about that. And that's repeated, maybe it's important. Main ignition system is used primarily during ground starting. Secondary function of the system is to provide standby protection against in-flight flameout, which could occur during takeoff, landing, be really bad during takeoff, bad weather operation, or when operating in anti-ice bleed air mode. That's it on that a minute. Why, if I am using my bleed air for anti-icing, why could I be at risk for a flameout? If something goes a little wonky.
Can you ask the question one more time?
If I am using bleed air for anti-ice, I have that on, why could that put me more at risk for flameouts? Come in.
Like, you gonna extinguish it?
Why? So, keep on that thought path. Let's say, we're going to dive into the weeds a minute here. So if I'm using bleed air for anti-ice, am I going to take it off like at P3 where it's nice and toasty, or am I going to take it off up here at the front of my compressor? Yep, P3 because I want it nice and toasty, and I'm taking that air, putting it at my inlet or wherever I want.
So you're getting less pressure.
So I'm getting less pressure, less air for combustion. So now my combustion mixture may change if my fuel system isn't adjusting, if my N2 isn't adjusting. So if the engine isn't trimmed correctly, FCU isn't set correctly, and FADEC, if that's on the engine, something goes a little haywire, then I could have flame out. Also, if I have anti-ice on, probably what conditions am I flying in? Okay. Rainy, icy, sucking that in. So that's not great either, but questions on that? Yes. Joe.
I guess I initially thought, hey, we've got less air, so we've got different mixture, but our fuel control unit's not adjusting that automatically.
It should. So that's what I said. If you're not trimmed right, if your FCU is going well. So it should not give you a flame out. But if any parameter isn't correct, you are at higher risk for a flame out than if you don't have this one.
Okay, so
Which
this,
is why you might turn on your auto ignition.
this would only happen in a theoretical sense in the fact that something is already incorrectly
Yes.
set. Second question, as we're just talking about this, you know, secondary function is to provide standby protection against in-flight flameout. It sounds like a turbine engine would be very easy to restart if you're in the air with a flameout. Like you would just pitch down to get airflow through and apply spark. Like it should be pretty easy. Is that the case?
It depends what's wrong.
Like,
But
let's say
if everything,
you applied throttle too fast and
Yes, it's designed for an in-flight start, especially if you have two igniters firing. Okay. If you have only one igniter firing, there's chances are that you probably won't get that engine ready to flight.
okay. But with a two igniter turbine, it's fairly easy.
Yeah, it'd be harder to relight that engine in flight with just one igniter. So that's why it's critical to check them periodically. On our pre-flights at the Gulfstream, and I apologize, I was gonna other one from the other exciter box could be sparking at a slightly different rate, so you can hear them, two of them. So when we turn them on in a pre-flight inspection, we turn them on and listen for the two sparks, we only hear one. That airplane's grounded till we fix that igniter unit. Yeah, because if they ever had a flame on flight, they had a hard time starting that engine going.
Back to you.
I feel like, crap, where, there was a question about a valve that would shut off if you guys bleed air.
We're gonna talk about bleed air, actually, Kirk went to talk about that Wednesday.
Okay.
So yeah, we'll talk, that will be covered by one of us. Matthew.
Do there not a system to separate excess moisture out of the air?
So typically, if everything is set right, it won't affect your engine. But if something's a little bit off, that will make it more worse.
Remember, on every engine, P3 is a critical pressure measurement that feeds where? Either to the fuel control on an old system like the Beach Jet, or P3 is fed to the beta so that the computer can do all of the adjustments. Either way, fuel control needs to know what kind of pressure is in the diffuser, the burner pressure, in order to adjust the fuel. So when you tap bleed air, and we're tapping it off that compressor outlet area for bleed air, that fuel control better be set correctly to ensure that it's getting the right fuel for the loss of air, because the fuel control measuring P3. And that's what bleed air is coming from for AIs, or real close to situations. So, yeah, everything has to be adjusted properly, and when everything's adjusted properly, everything works. Don't worry about it. But you as a technician, if all of a sudden, the pilot turns on bleed air, and then he loses combustion, his parameters on his gauges are going down, so he doesn't in-flight air start, he comes back and says, hey, man, I turned anti-icing on, and I had a flame on. So you as a technician needs to go, oh yeah, I think I know where to do some research on that, to start troubleshooting. So that's why you learn all of this theory, and try to anchor it in so that you can carry this out in the field, have some idea of maybe where to go.
Any other questions?
You're still thinking, what else you got?
Nah, we'll just hold on.
Wait till we
I
get
was just thinking, like, that's a precarious situation to be like, do I want no icing, or do I want power?
No, here's the thing, normally there's no problem.
Yeah.
There's no problem. But if something's not right, or if something breaks, or whatever, and then that happens, you need to know that could happen and know where to go, manual, figure out what you're gonna do to fix it, because everything needs to be fixed. So, it could happen, but chances are it won't. In my career, I don't ever remember someone turning on anti-ice and flaming off an engine, ever. But can it happen? Absolutely. I have never had my house destroyed by a tornado.
That's a good example.
Could it happen?
Don't tell me that, Dave. Close it. Insurance is for. Any other questions? So, the main ignition system is going to be generally intermittent duty type, and then you have a low energy or low joule system called the continuous duty circuit that's incorporated within our ignition exciter box. Here's our exciter box, pull into number 1 plug, number 2 plug. And the low energy one, that's the same as the extended duty, so you can have it on for longer. Here is the lovely circuit example that Case will go way more into detail with. But here or 28,000 volts. Whoever had asked why it can kill you, that's why it can kill you. Fun fact of the day, anyone know what an AED is? Automated external defibrillator. If you plonk, flat on the ground, they don't detect it, or a regular heartbeat, throw on the AED and it boom! You know what an AED actually does?
Doesn't it stop your heart?
It stops your heart so that your God-given built-in electrical system can reset and then fire correctly after that. So, yeah, that will only shock if you have a regular reason. It's your fun fact of the day. So, any guesses on the average voltage of an AED that is designed to stop your heart? Good guess. Good guess. Good guess.
Voltage or joules?
I'll take either, but voltage is more impressive. So, on average, the general AED like we have out on the wall, generally, it will deliver 1,000 volts. How much is an igniter? 28,000 volts. It will kill you. It's going to stop your heart more stop than stop.
And here's the thing about joules, is when you're dealing with any really, really high energy systems, like lasers are measured in joules. One of the things about joules is that typically, if you go with Ohm's law, is that when you raise voltage, your amperage goes down to get the same amount of power, right? So that's why you can have those 30,000 volt high tension lines going across the cornfields, and the wires are real small because it's low amperage. And but the thing about joules, it's not only high voltage, it's got some amps behind it too. So there's a lot of energy in there, and it'll just kill you.
Somebody had also asked how long do you wait? So PT6 engine, now this is specifically for the PT6, you have to wait at least 6 minutes after operation. That's only PT6. Always go to the manual for whatever engine you're working on. Make sure you find what is required. Your life depends on it.
Can you go back one? Are you gonna talk about the bleed resistor in there at all?
Oh no, go ahead.
Okay. If you look on the lower right side of that schematic, you have the bleed resistor. And when you shut the system down, that bleed resistor will slowly bleed off that storage capacitor that's kind of in the middle of the schematic, because that's the thing that's holding that 28,000 volts. So when you shut it down, that bleed resistor will slowly bleed that off and make it safe. But when you read the manual, it'll say, don't trust that bleeder resistor. So if you waited 30 minutes and then you go in and remove the igniter in the box, when you pull that lead off the igniter, touch that lead to the case, just in case. And if you get a snap, okay, you just saved your life because you discharged the energy in there that could kill you. And number two, that'll tell you that bleed resistor failed. So that's why that bleed resistor is in there, but don't trust it because that resistor could fail. And that thing could stay charged for hours and hours and hours. So you might go in there and think, well, it's all safe, but it's not. So it's just one of those additional risk things that I want to share with you, is when it comes to this, you have to totally reset this box. And just make sure that everything's cool. Follow the manual, but normally what we do is when we take the lead off the igniter, just touch the just to make sure there's no other energy in there. Then you're good to go. And if somebody does get that zapped, typically if they're okay, then you just start laughing like crazy.
Oh.
When somebody gets zapped, I mean, it is funny, as long as you don't get killed, you know? Still laughing.
So now move into the auto ignition. I mentioned it, and then I said, welcome back to it. So here, the auto ignition is designed primarily to ensure instantaneous ignition if, during flight, the engine begins to lose power. So the way that the auto ignition knows if our engine is going to lose power is a sensing system either sensing loss of torque, oil pressure, or loss of compressor discharge pressure. So on the King Air, I'm pretty sure it is a torque sensor. So if it senses torque, all of a sudden dropping and nothing else has changed, if you have auto ignition engaged, it'll automatically turn on your ignition system without you even taking a minute to realize, deciding what to do. So instantaneous ignition. Yeah.
Is there, if that's going off, is there usually something like an indicator to let you know that happened?
Yeah, will be a light in the King Air. I think it's a top light to say, oh, auto ignition is on. Yep. What are our two types of ignition systems? Yes, low tension and high tension. And they're designed to use either DC or AC as input power. If it's a DC system, that will receive its power from the battery bus or permanent magnet generator. AC systems will be powered from the aircraft, so either the APU or you'll need an AC power cart if it's from the ground.
Does anybody have any confusion about the word tension in this? You kind of know what that means? No, the tension is like, well, low tension is a quiz and high tension is your final exam. Tension is just another word that they're using for whether it's low voltage or high voltage. That's all. In fact, those big power lines that run across the cornfield, they call those high tension lines because they're really, really high voltage. That's all that, where that word tension comes from. And then the PMGs, that permanent magnet generator, a lot of your old engines, Beechjet should have it, a lot of your PD6s have it. They have this little generator that attaches to the accessory gearbox, and that little generator feeds your exciter box. So you don't need any external power. All you need is to get that engine motoring, add fuel, the igniters are already gonna go because it's got that little built-in generator on the case, so that's how it goes. All of your modern systems now, especially with Baydex or Beats or something like that, they don't use PMGs anymore. They just use battery power. But just so you know, that if you work on an older aircraft, there could be a PMG, a little tiny generator about this big, that would feed the energy to the exciter box. When it's loaded.
Question? AC versus DC input sources. So with AC, you have better reliability at altitude and a better duty cycle, so you can have more time on before you have to give it a rest. They may switch from one plug to another, and whoa, almost dropped it. If it's an AC low joule system, you might not have any time limit. You might be able to leave it on as long as you
gotta have a battery to start the APU, right? Then once that gets up and running, then you use the APU to start the aircraft, and the APU generally has an AC generator to help feed the large airplane. Because large airplanes use AC, not DC. I mean, they use DC in certain areas, but basically an AC airplane. That Gulfstream you were on last week, that's an AC airplane. There's a big AC generator on it. So it's AC that powers everything, including the igniters and stuff that we use in AC. But just the APU, just to start it, you gotta start it off with batteries. I use a DC system. Simple as that. Yes.
So, if it's AC, that power cord you plug in, does that provide AC or is
Yeah,
it?
AC.
Okay.
115 volts, 400 cycles. And if you learn the cycles from electrical class, you're learning that this stuff up here is 60 cycles, but in an aircraft it's 400. Yes.
Does every turbine have an auxiliary power unit, or is that just larger ones?
Just larger airplanes.
And what makes it necessary to the
Yeah, when
starting
you
load?
push, let's just take the Gulfstream for instance, or a passenger jet, airliner. Let's take the Gulfstream for instance. When we push it out on the ramp and get it ready for passengers, we start an auxiliary power unit. We start an APU. That starts on batteries. It's an AC system. Once the APU is up and running, it supplies two things to the Gulfstream. Number one, AC power to power the aircraft. Remember, the engines aren't running yet. Powers the aircraft, gets everything up and running electrically so they can get all the avionics up, get their computers programmed, blah, 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 blah. And the second thing it does is it gives bleed air to the cabin. So you can put heat in there or air conditioning on a hot ramp. So that's the two things the APU will supply. And then when you get in there and start the engines, the APU also supplies whatever it needs to start the engines. Once the engines are up and running, then typically you'll shut the APU down. Typically. But some aircraft, they leave the APU running until they get up to, maybe 15, 20,000 feet, then they'll shut the APU off. Just in case it's a system, because the APU can still give electrical power, and the APU can still give bleed air and pressurization. At some point, he's never had a catastrophic failure of the engines. Those are called in-flight APUs. You'll get into that. So that's just a high overview of it, okay? But APUs typically start off with DC because there's battery, and then they can start the larger airplanes with AC. Yes.
Just like purely out of curiosity, the aircraft y'all were letting us walk in, I think it was like the family aircraft or something. Anyway, a couple of us were wondering where the APU was on that, because I've usually envisioned them like in the very back of the tail, but this one we could walk up the ladder and stand there and we were not able to see it. It almost from the exhaust looked like it was sitting like horizontally up forward if that were.
Exactly right. That's exactly where it is. So when you went up that ladder in the back, you're facing forward, and if you would've looked straight forward, you would've seen this kind of a boxy thing. That's the enclosure for the APU. So all APUs are enclosed in a fire shield to protect the airplane. And then you typically have the inlet on the left-hand side of the fuselage, and then you have the exhaust outlet on the right-hand side of the fuselage. Yep, you're absolutely right.
So if you get that APU running fast enough, you could use it as like a right turning.
Right. Well, okay, that's a good thought, but when you have an APU running and you're extracting as much energy out of there to run a big generator or to run bleed air, how much thrust are you getting out of that APU?
Not much.
Not much at all, just an exhaust, so there's really not much to push it.
You're talking about the future George pilot.
Every factor.
Set off all the lights. We gotta make the right turn.
So I hope you understand, just a little bit more understanding on your action systems. But the most important thing you need to know is, Chad, it'll tell you, so just be careful. Follow the manual, always follow the manual.
system has a longer expected transformer exciter box service life because it's not running at such a high voltage anymore. Comparing our igniter plugs to spark plugs, the electrical sparking device used to start the burning of the fuel air mixture in a combustor. So if you need, bam, definition, there you go. And they don't try to compare them to a spark plug on a reset. They're very different. So somebody had mentioned that our gap for the spark to jump is much wider in our igniter, much higher intensity spark. The shell on our igniter, typically nickel chromium alloy, center electrode, usually of tungsten or iridium, and our warning again, do not touch igniter plugs until here 5 to 30 minutes. So some engines maybe 30 minutes after the engine has been shut down.
I think those are the same numbers we use for checking oil too, right? Is it 5 to 30 minutes
How
after
about
shutdown?
that?
Somewhere in there.
Yeah. Something that you will be asked about, not on your midterm, we're getting ahead of our midterm information now, but mark this down for your final or for your written, power plant written. So we're comparing high tension and low tension. In prepware, you may have already run across, but they like to use the words for low tension, self-ionizing, or shunted gap. And that will be because the air gap on between the electrodes on our low tension actually becomes ionized as the semiconductor resistance drops. So that's why, so we have in here, number 5 is our ceramic insulator, and then running down the center is the center electrode, a little tungsten tip out here, but it has bigger gaps, so self-ionizing or shunted gap. They may not even have low tension anywhere in the verbiage. They'll just ask you about self-ionizing or shunted gap. And then our high tension, just a little bit different construction than low tension. Questions on that? Then, yes.
So, for recips, we do adjust the gap, which you have to do that for, registry fixing.
You'll measure it, you'll do inspections on it, but you don't, it's not something.
Yeah, this is a fixed gap, but it will wear. So when you do an igniter inspection, you're just checking that it's still within the gap.
And it's not, you just.
And if it starts eroding too far, then you just put the igniter.
Are igniters like pretty expensive or are they fairly cheap?
Yeah, they're fairly pricey.
That's turbine.
Yeah, it's a turbine.
So there's one other way, kinda, you can have ignition, and that is glow plugs. These are old, but we have them on our King Air. Depending where you work, maybe you'll have a very old engine and need to be familiar with glow plug use. So it's a resistance coil that goes to very high heat, and they were designed for extreme low temperature starting. So in Alaska, glow plug could be great. They are common on old PT6 engines. But the cool thing
turbines are cooler. I was thinking,
Class
like,
we're in.
what if they had made the original Top Gun and he wasn't flying a jet, he was flying a turbine? I'm sorry, a recip.
E51?
And if he, you know, it'd be okay, but it'd be, imagine if he was like, hey, can I come in for a low flyby? They're like, no, pattern's full. He comes in, and the guy in the tower has his cup of coffee, and he's just like, and he's just like,
Yes.
it just doesn't hit the same.
That does it.
Turbo.
Or Top Gun 2 where they're going down that ravine.
Yeah. It just wouldn't hit the same. Now there's another movie, what's it called? It's with Glenn Powell, who's in the second Top Gun. He's the guy, he's
lights were to go out, we wouldn't be able to find the doors.
Actually, it's not.
They actually, there is emergency. The lights go out. Alright, gather in. Missing people. Uh-oh. 1,
Flattery will get you.
2, 3, 4, 5. Oh my goodness. Uh-oh. 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 We need a more severe punishment.
That's what we're testing.
Who's all testing? Oh, yeah. Yes. Who else is testing? Okay. Yes, Grant is. Two. That one. That one. All right, we're all gonna go ahead and keep rolling cause we got stuff to cover. Yes.
It seems like less things could go wrong with the oil. So why do we use?
That's a perfect lead-in for Kirk to talk about that and then a little more about.
So are you talking about the coil on the?
Yeah.
Yeah, the glow plug.
Yeah, the glow plug. These igniters are much better. They're much more effective.
Okay.
Because typically what you're dealing with is a lot more high altitude too, than what some of the smaller engines will do. High altitude. You know, it's all different pressures, high altitude. You're dealing with a 21 to 21, 22, 23 to 1 compression ratio on a jet engine compared to a piston, which is only what, 9, 10, 12, whatever it could be. So all the energies are different. That's why you gotta use those high energy ignition systems, and they're very reliable. Do they fail? Yeah. That's why you have two, you know, but they're very reliable. So I wanted to take a minute and explain this, just so you understand this. You're gonna see that word shunted before. Have you talked about shunting in electrical class? You did. So, okay, good. So if I had a battery and I wanted to discharge that battery, I can put a resistor across there. It's called a shunt, okay? And then slowly discharge that battery before I go on and test it and do capacity checking and then recharging. So on this igniter here, if you look at the very tip, here's the outer shell, then here's the center electrode. On this one, it's just insulated so that the gap, the spark would just spark right across to the metal. The self-ionizing or shunted is this material here is filled in with a semiconductor. So it conducts a little bit. So if you see this semiconductor area right here, all the way through here, so as the energy is firing down the center electrode, the energy is also energizing the semiconductor at the same time. So it tends to ionize this area, and because it's ionized, the spark can now flow across here easier by following that ionized, energized little field that's in here. So the spark can jump that gap easier. That's what it means by self-ionizing or shunted, because that area is a semiconductor. Yes?
Wouldn't it make it safer though, too, for like the lead off or something? Because it technically also bleeds itself off.
Yeah, a little bit, yeah.
Does shunted apply to both high tension and low tension?
No.
No, it's just the low tension?
Mhm.
Why is it that high tension doesn't use that same?
Because it's so high tension, it's gonna jump that gap.
So
The
it
low
doesn't
tension,
use itself.
it needs help jumping that gap. So they usually make it a self-ionizing or a shunted. And also, the low tension is usually used for continuous. So let's say, for instance, you're flying through inclement weather. It's time to turn the igniters on, and those are gonna be firing at low tension because they might be firing for half an hour, depending on what kind of weather you're in, things like that. Okay? I just want to explain the shunting and the self-ionizing on that, and it should be good.
I'm sorry, I must have
Yeah, real common usage is that if you're ready to take off and you turn on the runway and it's raining, you got a wet runway, you're just gonna turn the igniters on. Just let them fire, okay? And then you're gonna go barreling down the runway, and if you get a lot of water and stuff kicking up into your engines, it'll, just in case you get a flame out, those igniters are right there to relight it, right away. So then, as you climb out and everything clears up, if you're still flying through rain, you may leave them on, you know? And then eventually, when everything clears up, where you go over the tops, you know, where you don't have any precipitation, then you turn the igniters off.
And
Now-
it's not as ideal to leave the high tension ones.
Oh, no, it's too much energy. You couldn't leave those on for a long period of time, you'll burn the units out. That's it.
Thank you. Any other questions? Yeah.
The high tension, once they do eventually burn their temps out so far, like, jump, since there's nowhere to pull the electricity to the ground, wouldn't that just fry the whole box?
So you have to do inspections, and that'll be on the slide, making sure there's discharge on. Yeah,
So you just don't want to do that.
right, yes. So you talked about glow plug, so, inspection and cleaning, next slide will have what you're looking for. Do not ever use abrasive grit blast cleaning. You'll destroy those tips. You can clean it with solvent and a soft brush. Keep in mind that the electrode inside can be easily damaged. So we're gonna look at some examples of measurement checks, checking ceramic. Those are common inspection items on these plugs. If it's not within tolerance, discard it, get a new one. If you are inspecting your igniter plug, looking, be carefully measuring it. Oops. Bank account, bye-bye. You had to buy a new one. Whoops, there it is. If you drop it, you don't know what damage was done inside. Buy a new one. So keep that in mind
Yeah,
whenever.
go take it and list it on eBay.
Whenever you're pulling one of these out, make sure that you have a drop cloth or something to, because all of us get dropsies from time to time. So double check, be very, very careful, always have it over something that it won't fall. Yeah.
Maybe a dumb question, but how far of a drop is this before you know? If you're only
Okay,
at the table
here's
and
a
you drop
scenario.
on the table.
You are flying your wife and grandma, mother, favorite dog in aircraft where you drop this just like 2 feet. Is your wife's life, are you comfortable with her life in the hands of your maintenance on dropping that?
No.
No, well, it's toss the answer to Kirk.
You know, what you'll find, and of course, it's been a while since I've seen this, but it's not uncommon to list items where it says, handle like eggs. Okay? A lot of gyro boxes, electronic gyro boxes, handle like eggs. I would handle these like eggs, and your spark plugs too, for your piston engines, handle them like eggs.
So does that mean if you drop it 2 feet, you take an egg and drop it and if it breaks, it's good, and it's not good, but if it doesn't break, then it's good?
Again, how much do you love your mother?
Really good, nice short list.
How
Now the ceramics, just real quick, yeah, that's a good one right there. The ceramics inside, that's the insulator, it's extremely hard. The white ceramic on a spark plug is all aluminum oxide. Aluminum oxide is basically a non-conductor, and it's a ceramic, and it's extremely hard and very heat tolerant.
certified garbage can before you bake. And then this is looking cross-sectionally and seeing that wear down more and more. So you would take whatever special tools manufacturer requires to measure that, make sure it's either within tolerance or that you need to get a
So if it's in tolerance, it's airworthy, right? If it's in tolerance, it's airworthy, right? You can put it back in and run it? Presumably. Okay. If it's out of tolerance, then it's not airworthy, and you keep it out, right? So is there any point that you would toss an airworthy igniter and put a new one in anyways? Thank you, that's exactly where I was gonna go with that. If it's even close to being out of tolerance, don't put it back in. Because chances are it could be out of tolerance halfway through its next inspection, and then compromise its operability. You gotta use your judgment to say, wow, this is pretty close to being wore out, let's just put a new one in. Yes.
What are common inspection times for these?
For the igniters, depends on the engine. I would say, gosh, I'm trying to remember. I don't know if it's 12 months, 24 months, could be 12-month item. I think it might be a 12-month item.
Any other questions on ignition systems? We'll hop into starting systems. Going.
Actually, I think go by hours. I think the igniters goes by hours, operating hours. So it could be a couple hundred hours, could be 500 hours or something like that, operating hours. Yeah, yes.
So do they not take into account when they're making the tolerances, I have this inspection time limit, and I'm gonna set the tolerance to be that if it's, so that when we put it in, and it's at the low end of the tolerance, it'll still be fine for that amount of hours?
Not necessarily.
Not necessarily.
Not necessarily, because you don't know what kind of operating conditions that igniter's gonna go through, or if they operate, I don't know.
Yeah, I'm just thinking generalized too, it's like, if I had a crankshaft or something like that, or whatever.
Right.
Like that, thumb.
Yeah, when you pull it, check it, if it looks like it could go another year, and you've got a lot of good tolerance on it, just stick it back in.
Any other questions? All right. Moving into starter system, and this will be APA chapter 80. If you happen to get to a lab where you happen to come in, you already happen to need to know the APA chapter. So, couple people, well, actually, no, I'll ask these individually. So, on here, what component is our starter going to be connected to get the starting process rotating?
The high pressure compressor?
Excellent, high pressure compressor. So your innermost one, typically with your high pressure turbine, start turning that compressor, which starts turning your turbine, which is turning your compressor, which then flows air back here, which gets these turning, which then gets that turning, and starts to start the whole process. And on a, here you go, so gas turbine engines generally started by starter power input to the main accessory gearbox, which rotates the compressor. And you mentioned if we have two spools, the starter rotates the high pressure compressor system. On the PT6, anyone remember the special name for I almost said it. This section of the engine is unique to turboprop. So instead of N1 or N2, excellent, NG, that refers to gas generator. So this is our gas generator because it's generating gearbox. And kind of talk through it on there. Your starter starts to turn. Your compressor, that's turning that, which then is turning that until we get combustion going, and then our turbine will be driving our compressor. So starting that start cycle. And what happens then if we are indicating good airflow? And also, most commonly, igniters will be firing along with our starter beginning to rotate. So when we get up to whatever manufacturer requires of NG or N2 speed, we got enough airflow, then we introduce fuel, have a burn happening in our combustion chamber. And do you remember the name, the term for the speed that we reach when we can then turn off our starter? Ooh.
Self.
Yes. Yes, self-sustaining speed. So now we have enough combustion occurring that's turning our turbine fast enough to keep on turning our compressor, giving us enough air to continue the burn, to turn the turbine, and is now self-sustaining, not relying on the starter.
Is there a certain end position for that, or?
Yeah, for every engine. So PC6 low idle is 50 to 55. A technical self-sustaining speed would be a little bit below that.
That's what I was wondering.
But on the King Air, we manually shut off the starter switch. On the Beach Jet, I think it's all automatic. Yeah. So it senses when it's passing self-sustaining speed and automatically, we'll talk about it, disconnects it.
And there's always an override, so you can watch the
Yes.
light where it says you got ignition.
Yeah.
And then you start getting that, maybe about 48% on a lot of the jet engines is 46 to 48% is usually self-sustaining speed, but you don't always get it above that. So then you watch the lights, that as you're approaching idle, those lights will go out, starter and ignition. And if they stay on, then you can manually turn those off.
If we have an air starter, which we'll talk about, it's going to be up at the front of the engine. Any thoughts why that might be? Typically. first indication of successful start is light off. Questions after I confused you? Okay. Now, hung start or hot start. So, king air, I didn't forget. So when I tried to start the king air, earlier, before we got into all the troubleshooting, who was in there with me? Yeah. So we tried to start the right engine, and I might get my 2 times mixed up, so keep me straight. So we turned the starter on, and we had an odd indication in fuel pressure, which is not abnormal. So that's, yeah, making things better on a well-running airworthy aircraft. You could depend on your gauges. And fuel flow, yeah, we got to where you introduced fuel. Yes. So we turned starter and ignition on, got our prop turning, oil pressure was good. Fuel is a little unusual, but we're like, we'll try this. So then I introduced fuel as we came up past 16% NG, and we had light off. It came up, and then it came up to like, did it come to 50? Did we turn start off, or did it lead off before then?
We didn't get
Correct.
too
So it's almost coming to 50, and then bleeding back down. Like, this is not normal. We shut down, cut off fuel, starter to off, 30-second rest, and then motored it for 30 seconds before you can manual to get rid of fuel. So then talked to Ryan. Ryan saw a little puff of flame, which we found out from his dad is not abnormal for the old KT6 style fuel nozzles. Because it's just a single manifold, and all the fuel nozzles, at first all of them have low start flow, and then all of them increase flow, because it has an old system. So he said that's not unusual. But we got, so then Hannah and Ryan, Friday, while we were all on a happy field trip, they dug into it, and fuel filter was nasty, so I think they replaced that or cleaned it, or fuel strainer. And they checked the glow plugs to make sure they were working, which Ryan sent me the video, they were beautiful. So they really cleaned out the fuel system, got tons of gunk. And I'm trying to think if they checked anything else. So then Friday afternoon, I did a run. In the initial run, I came up to 50. I think Grant was in there with me again. And then when I turned the start switch to off, my NG started to drop, which means I had what kind of start? Hung start again, because apparently didn't have enough combustion to keep that self-sustaining, and it was just hanging on the starter, depending on the starter for rotation. As I saw that drop, before I reduced fuel, I glanced at ITT, and that was actually really drastically dropping. So I think I had a flame out, is what seems like it, because my ITT really dropping off way more than normal. So cut fuel, starter off, already was off, waited 30 seconds, rotated it. But Ryan didn't see anything bad outside. All my fuel gauges were normal, so good normal pressure, good normal fuel flow. So we decided, okay, we'll do one more start. We have another start cycle left. All the gauges are fine. That one went beautiful. So it was what we could determine: fuel system, clogging, dirty filter. And probably, because the filter was so gross, there's probably some contaminants in the line that maybe got stuck in the nozzles, possibly didn't have enough fuel to sustain the burn on the first run, got cleaned out. So whoever runs today will try the right engine again, pull it from the back.
The left is not correct.
It is, it has been, thankfully, yeah. So, we talked about something that we look for on a King Air before you even attempt any start. So this is on start, like starting up, yeah. Yeah. Low voltage. So if you don't have enough voltage to your starter to get that whole thing rotating as fast as it needs to go, it'll never even come up to self-sustaining speed. Come to 30 or whatever, and not even get where you need. So really important to have the voltage you need. And that could be from what, if your starter doesn't have enough power? The battery? Or you forgot to plug in your power card? Different things like that. And so let's say I was not following procedures, and when I saw on our first right engine start, my ITTs are great, but I was bleeding off on my NG. Let's say I was like, you know what? I think there's more fuel. Help it out. Even though we have a hung start, I'm gonna go to high idle and throw in some power levers too. What would then happen?
Hot starts.
Hot start. Because I don't have enough air, and now I have too much fuel. So any attempt to accelerate by adding fuel during a hung start will have to result in a hot start, and then combined with a hung start, you have insufficient airflow to support further investigation. So for either of those, you must shut down according to procedures and investigate. That means confer with Ryan. Figure out what's going on. Why did it do what it did? Any questions on those? So, on the King Air we have an electric starter, but electric starters are not widely used on flight engines because they're heavy. So small engines, when you only need a small starter, like small PT6 engines, they will have electric starter, but in the whole world of turbines, not common. They are widely used on auxiliary ground power units and then small engines. And most will contain an automatic clutch mechanism, which we'll have pictures of, to disengage the starter drive from the engine. That helps prevent the starter from applying excessive torque to the engine drive. And it acts as an overrunning clutch, which prevents the engine from driving the starter. Here is fun and exciting schematic of our ignition exciters plugged in with our starter generator, because oftentimes when your switch will be for starter and igniters both, and then like on a King Air, switch it down and starter only, but they will have on the switch to start both of them. And you'll get way more in the weeds with that in case if you haven't yet. You will.
Does anybody struggle looking at a schematic? Good. Because you're not alone.
That's right.
Most people do.
Yeah.
But the more you play with them, the easier it gets as time passes.
It's awesome.
Again.
It's a huge.
The next slide, Elise. Questions? Alright. So here's what I talked about, that clutch and our ratchet drive gear. So when we're engaged, these little paws, not paw, but pawls, are engaged. And then when we disengage, that clutch back in and not be driving those gears. And see, I don't think they have a shear shaft showing on this diagram. There will be on the next one. So there are several built-in things to help save most of your starter. So this is one of those that'll automatically disengage. And then, still can't quite see it, but there will be a shear shaft. Does anyone know what it means when they say a shear shaft? Go ahead.
Oh, it's rated for like a specific amount of torque, and if it's given any more, it'll just break.
Exactly. So the shaft will narrow down a little bit, so it can shear and break off at a certain torque. So that replaceable portion, that shaft, can be replaced rather than your whole engine shaft or your entire starter generator. You just replace that piece because it's meant to shear at a certain over torque.
And because the item is so small, it's a common carry item on board an aircraft, it's a spare parts kit.
The starter generator, widely used on small gas turbine engines, turbojets, turbofans, turboprops, turboshafts, and combining your starter and generator together provides weight savings, makes it more feasible for small engines. Then we move into air starters. And a reminder, generally, they're going to be on the front of the engine to get cooling air over them. But we'll look at this drawing and then show you specifics. But we have our air inlet coming in, and look at that. We got a little turbine, our starter. So air spins our turbine and then goes out. But then our turbine is going through this reduction gear and into our engine drive shaft. So air spinning this, reducing speed to the drive shaft. And for fun, Top Gun 2 Maverick. Remember that scene where it's like, get the air starter, and you kind of plug it in and disconnect it. Fun and exciting. Alright. So, it is a type of low pressure air motor developed as high power to weight ratio device. And has approximately, good, Joe? Kurt? He's facing up. So, an air starter has approximately 1/5 the weight of a comparable electric starter. A really good weight savings. They're used on most every large commercial aircraft and becoming more widely used on corporate jets. It's a low pressure, high volume air source, about 45 psi, going at 50 to 100 pounds per minute. That will be supplied to the starter from a APU, GPU, or cross bleed air from an already operating engine. And to turn it off, to terminate the air supply, normally from the cockpit, or it can be automatic as sensed by a centrifugal cutoff switch. Turbine starter, the turbine in the starter will rotate 60 to 80,000 RPM. That's why we need the reduction gear system in it. And it will usually be geared down 20 to 30 times so that then we have high torque. So, pretty cool system. Very cool thing, when you shut down the engine as it spools down at about approximately 20% of engine speed, those paws on the overrunning clutch of the starter re-engage so that then they're riding on that little ratchet. Joe.
60 to 80,000 RPM.
Mm-hmm.
That's astronomical. Does it need like an oil lubrication source, or is it oil?
Just show it in, you still need, I'll throw it to Kurt.
Yeah, it's got a self-contained little oil reservoir in it. It has to be checked periodically.
So, that re-engage can damage some starters, so that's only accomplished with within manufacturer's recommended limits. And here it talks about the shear shaft I had mentioned, so brakes at predetermined torque to prevent damage to the engine. And another safety feature to prevent the starter from reaching burst speed if the inlet air does not terminate on schedule. So if somehow you don't get that air to stop, the airflow at the turbine nozzle vanes on your air starter become choked. So then the turbine wheel will stabilize at a controlled overspeed. So back to that choked airflow as it's going through and you're reaching sonic speed and it forms a shock wave and choked airflow. It cannot go faster than that. So and that's happening between each little of the turbine blades on your starter turbine wheel. So that it will be overspeed, but it won't go beyond that. So it's a controlled overspeed. Joe.
2 questions. What's the overspeed on this? Like 200,000 RPM?
I don't know what it is.
Second thing is, I'm having a hard time wrapping my head around this. At this point, 80,000 RPM, why don't we just leave it running and let it double as a gyroscope? Like, that's wild.
Already wild. Matthew.
I have a serious question.
Thank you.
Can this, in case of an engine out during flight, use ram air to restart?
Yeah. Good question.
Some aircraft, you can start the APU all the way up to like 25, 30,000 feet. So if worse comes to worse, depending on the aircraft and the design, you could restart the APU in flight and then use that to help start your engine too. That's rare, but typically when you're in flight, just the ram air will be enough to keep the engine spinning and relight it. One of the things I just want to mention here, and I'm not sure if we'll get into it later, if we do, great, but sometimes you'll hear the term high RPM, low torque to low RPM, high torque. You'll hear that term. And I'm not sure, but it may be on exam, that term. That typically describes like what's going on here with an air turbine starter. You're spinning this thing at 80,000 RPM, and that wheel alone is very low torque. Very low torque. So because it's so high RPM, you gear it way down to a gear ratio to where you now have a real low RPM, but incredibly high torque to spin that engine to get that whole thing going. So you might hear that term, high RPM, low torque, to low RPM, high torque. You're just reversing it.
Here is a diagram of the air turbine starters coming in and turbine here going to multiple gear reduction. And then here are the clutch ratchet. Here's the shear point, so it's next down from our drive shaft. And then the little paws here, the straight in look at it, the little paws on our ratchet that can engage or disengage.
Now, they call those spray clutches. Spray clutches have been around for a long time. Use them on, 50, 60 you ever forget that word, just think of the street that smat is on,
Ah,
except that's got a UV at the end of it, right, spraying, basically. But the spray clutch, it's been around for decades and decades and decades, and it's still very common in use today. Probably the guy that invented it.
These also will have a duty cycle, so like on the all starters generally will. So you pay attention to that, what your limits are. It's usually 3 to 5 minutes. And then a cooling off for 2 minutes. That makes sure you're
And that does have an oil reservoir in it, you can see that magnetic drain chip detector on the bottom. So that's a common inspection item where you pull it out, make sure there's no metal on the magnet in the back there. You have to do oil changes on that periodically too, but not very often.
This is some of the air sources, and we'll have another presentation on just the air. But you can have from ground power cart, air coming in for your starter, or you can duct it over from another engine, or you can bring it from the APU. So those are all sources of air to start your air starter. Quick little review. What does it mean when we talk about engine stations?
That we, I mean, stations, it's different sections of the engine, like PT7.
Exactly. So, from the manufacturer, setting up what each portion of the engine is. So, numbered location along engine length or along gas path used for the purpose of identifying pressure and temperature points and component locations. So, here we have what would PT7 on this engine be?
The total pressure at section 7.
And what pressure is that on this?
Low pressure turbine.
Excellent. So from an outlet pressure, what would TT2 be? Someone else. We can see, yeah,
Compressor inlet temperature.
beautiful. Total temperature at station 2, which is our inlet temperature. Just make sure you are familiar with all of those. If I were to say P3, what's that? Diffuser
Pressure.
pressure. Very good. One last little thing. Oh, sorry, did you want to? To talk about with the accessory gearbox, and again on PT6, this guy back here, and I didn't get to talk to all of you, but you saw it, hopefully, when we were at Amway. Whereabout is it on the beach jet and on the engines you're looking at?
The bottom.
Yeah, big old thing on the bottom of the engine. So, there will be a system of seal drain tubes connected to each drive pad, so each of those places where you can put an accessory. And those drains are going to be routed to the bottom of the engine cowl. So if you happen to look on the bottom of the engine cowls, or if you look at our beach jet, you'll see lots of little drain areas. There are wet drains and dry drains so that you can determine the failure of seals and their condition. So, a dry drain should be dry. A wet drain may be wet. So if you see a dry drain, wet, better investigate, figure out what's going on. Leakage is generally minute and presents little problem as it leaves the drain point into the atmosphere.
saw oil coming out of there. Yeah, you do. Because a lot of times we'll use one witness drain to catch whether the oil seal is leaking on the accessory drive case, or it's leaking from the seal from the fuel pump into a common chamber. That little space where the pump engages to the gearbox, there's a little bit of space in there. So if the seal on the gearbox leaked, you'd have oil coming out of there. And if you had fuel coming out of there, then the seal on the fuel pump is leaking. So one witness drain, that's called the fuel pump, you could actually have oil coming out of there, then you just now, you have to pull the fuel pump and change the seal in the accessory gearbox, because oil is getting past there. Just one of those fun things to know.
Any questions? All right, take a quick little break and come back at 40. And we'll talk about the laptop. So I'll leave that to you for Wednesday. And then maybe, so tomorrow night. Wednesday.
So I get text from Todd saying, hey, I wanna kidnap this guy. I wanna kidnap
Yeah.
this.
And then I'll have
I decided to kidnap Grant Miller. What a wonderful young man. He came locked and loaded soon after steps out of the ballpark. He was already started on his airframe. So far, hitting 100%. He just finished.
but I'll have that all.
It's
Which
finished.
one?
He finished
Which
everything.
is what the main.
So he got general and airframe together.
That's very good.
Probably
Yeah, I'd like to, yeah, what are his tips?
Yeah, so I know that it's gonna be high demand. Everybody would talk to him
And
again
Nick.
today. Well, first.
Well, I don't,
some around. So Israel, you can run the King Air. If Jonathan makes it in, then he can also run the King Air, but since he's late. Late. David late. Geese is late. Kurt is late. Shame upon them. Question.
Shane and I didn't technically get to ride.
So because I had you already scheduled for this today, I bumped you to, yeah, we should be able to get it done Wednesday after our meeting is done. So I didn't, you're not forgotten. You just got reshuffled. Okay, so as I was saying, when we were starting on time, King Air runs will be riding Clayton, which they knew, and Israel also knew because he was here. Israel and Jonathan, you'll be doing instead of since Randall's not here. Okay, and then for fuel nozzles, let's see, Carter and Jed, you'll do fuel nozzles. Marcy, Isaiah, and Kurt and Joe. So again, the three groups go together with Nick to do fuel nozzle testing. Only testing the nozzles at the test area, and then if you all get an opportunity, you may also remove nozzles on that engine or the ones out there, not the one with the blue bar over the top, but other engines, the one on the stand, and just ask if you're not sure. And then, let's see, Matthew and Thomas, did you do the Allison compressor yet? Okay, so I got you there. You can, is there anyone else that needs to finish up the Allison compressor?
Me and Christian do.
Okay,
We just need to put it back together.
okay, so just don't get their engine. But the other two Allisons, you can pick whichever, unless somebody else still needs to finish. Okay, so Zach, and let's see, where are you at on here?
Bottom.
Oh, so
It
you,
works out.
perfect, so that works out, excellent. So then, so you should be able to get that done today. Then the rest, let's see, uh-oh, Ava's not back, and Grant's not here. So I'll put them, probably shuffle some of this around. Anyway, so then, let's see, Mike and Jordan, thanks for being here, appreciate it. And Caleb and Shane, and Gordon and David, and hopefully James is around somewhere.
I saw him like
Okay.
10 minutes ago.
I give you permission to do whatever is necessary for him to complete the lab. Within your Christian responsibility. As Jesus would. Okay, so this is doing the borescope on the PT6 engine combustion section. So that's using the twirly whirly, which I have on my desk. I'll let Kirk get it because you are not to do that without an instructor present guiding you in the, I forget the correct name, insertion guide tube. My bad, okay. Alright, so if like 4 of you gathered around works, great. If it's easier to do 2 at a time, but just start with Mike and Jordan, and then just work through in order, top to bottom. And we'll get Ava and Grant on another day. So hopefully those 4 groups will get through. If not, we'll work it in. Alright, any questions? Confusion?
Yes.
Yeah.
So, looking at Shane and I's schedule,
Yep.
we're doing the combustion section today.
Yep.
Op-
Oh,
potentially
look at
King
that.
Air
Isn't that
tomorrow
very funny?
Or Thursday?
I think, okay, I didn't know if I should be back tomorrow.
Gotcha.
If I'm not back tomorrow, you'll already have an alternate.
Okay.
So, yep,
And if you're not here tomorrow, just move left.
correct. Yeah. And I'll have, after today, I'll you have that up, and then you'll very likely be answering questions from the manual for the lab. You don't have to answer those questions before you go to the lab, but if you have it as a reference, as you're working through, like, oh, hey, one on this page, it's asking that question in the lab, I can go ahead and answer that.
So isn't it 9A or 9B?
So it'll be both. 9 part,
B looks like
let's
it's,
see. Yeah, so 9 part 1 will be all the Moodle questions about nozzle testing. 9 part 2 is the one, let me just go there. Refresh from Friday. So it tells you to remove, inspect, test, reinstall fuel nozzles, test spray pattern, you're gonna do a leak test. So all the testing part, you're only doing with Nick, with nozzles that we designated that we want you to test. The remove, inspect, and reinstall will be on a separate engine of your choice whenever you can fit it in.
so you just want us to pick one appropriate nozzle to write this short on?
Correct. So do it on whatever engine you're removing a nozzle from, because that engine will have, hopefully, the data plate.
Okay.
Where all the nozzles at Nick's station, we're not sure which engines they came from.
So we're just gonna pretend that all those nozzles are like, we took off all the nozzles for this hypothetical.
Yes.
Okay.
Yep. Yep. Any other questions on that? Okay. And Ava, I had you with Grant, so I'll just have you do